So let's go and take a look at number 2 to solve it. So again, for number 2, we have to use quadratic formula. So we should get x equals -2 plus or minus the square root of b squared, which becomes 4 minus 4 times a, which is 1, c, which is 8, all over 2 times 1. Simplifying it, we get -2 plus or minus. We get -4 here. Oh, sorry, 4 minus 32, which is a -28 over 2. And again, we get two answers, -2 plus or minus, but it's imaginary, I root 28 over 2. And those are our two answers. Very easy to do. All right, so let's take a look at number 3. Now, for number 3, we want to find the zeros is really what we're looking for here. Whoops, my bad. We're really finding the zeros. So we're trying to find the zeros for this one. So we have to use the P or Q stuff. So we're going to take a look at a few here examples. So we go, our P is 9, so we get 1, 3, and 9. Q is just 1, so it's just 1. So our possibles are plus or minus P over Q. So it's plus or minus 1 over 1, plus or minus 3 over 1, plus or minus 9 over 1. Now, it's a power of 4, so that means we have to find 2 by our synthetic division method. I'll try 1 first. 1, 6, 10, 6, 9. Bring down the 1, 1. This becomes 7, 7. Now, if you notice right here, it's just getting bigger and bigger and bigger. Chances are that's not going to work. Now, a hint for you is if you remember the P&I charts, there are no sign changes. That means there are no positive roots. So I didn't even need to check 1. So I'll check -1 instead. 1, 6, 10, 6, 9, 1, -1, 5, -5, 5, -5, 1, -1, 8. So -1 doesn't work. But again, I don't have to try positive 3 because I know they're not going to work. So I'll try -3 next. 1, 6, 10, 6, 9. We try it. 1, -3 is 3, -9 is 1, -3 is 3, -9 is 0. So it works. So one of my roots is -3. Now, I'm going to go and check -9, see if that works. Again, I don't have to reinvent the wheel. When I use my -9, I'll use what I left, what I reduced. 1, -9, -6, -54. That's getting kind of big right there, so that's probably not going to work. So, positive 54, even worse, you know. So what I'm going to try again, I'm going to try my -3 one more time. Maybe I have a multiple root. 1, 3, 1, 3. 1, -3 is 0, 0, 1, -3, 0. It works. So I have another one at -3. I should have checked that one anyways. And now my last two come from my reduced polynomial. X squared plus 1 equals 0. And we've solved this one already. We get x squared equals -1. Take the square root. We get x equals plus or minus I. And those are our other 2. So we get our 3 zeros right here. 3, -3 twice, and and plus or minus I, which gives me my 4 roots. So go ahead and try number 6, and we'll take a look at this one tomorrow as well, okay? And let's take a look at one more example down here. Use the graph below to factor the polynomial. Now, sometimes we're going to give you the graph, and this is kind of nice. So I could use my P&I chart or my P over Q stuff, but since I gave you the graph shows me my roots where it crosses the x-axis. And it looks to be a little bit past 1, not quite. But which one looks exactly is probably the 3. And not only that, it looks like it's a multiple root as well. So my first 0 I'm going to check is 3, or my roots. Now I should have 4 of them. That's where these all come from. So the first one I'm going to check out is 3. Plug it in. 4, -24, 31, 30, -45. Bring down the 4, gives me 12. which gives me negative 12, negative 36, negative 5, negative 15, so 15, which gives me 45, which is 0, so it works. So 3 is one of my zeros. Now, because it balances, most likely it will work again. So rather than rewrite my entire thing, I know the 3 is going to work, so I just plug it into my last reduced polynomial. Bring down the 4, we get 12, which becomes 0, and that's negative. 0, negative 5, negative 15, 0, so it works. So 3 also works. And now I'm left with a quadratic, and I can't solve a quartic, which is why I have to use my synthetic division. But by finding 3 roots, I've narrowed it down to a quadratic. 4x squared minus 5 equals 0. And this I know how to solve. X squared equals 5 over 4. When you take the square root, you get plus or minus the square root of 5 over 4, and you can reduce that to plus or minus root 5 over 2. And those are your remaining. Square root of 5 over 2, negative square root of 5 over 2. And those are your 4 zeros, which is what we expected to find. And you count them. 1, 2, 3, 4. All right, so we're going to take a practice these tomorrow and the next day, but you definitely want to try them, okay? And I'll see you guys tomorrow. Bye.